Welcome to the login node. This is Will. If you search YouTube for Home Lab or HPC cluster, you usually see perfect server racks, neat cable management, and enterprise-grade power setups. This is not that video. What you're looking at is a 6-node high-performance computing cluster built for under $1,300. We have 5 physical machines plus a laptop acting as a login node. It is stacked together with rubber feet. The cable management is a disaster, and the login node is connected to the internet via Wi-Fi. But here's the thing. It works just fine as a university research cluster for learning real distributed systems, MPI, and machine learning workloads. Welcome to the HPC from Scratch series. Over this series, I'm going to show you exactly how I built this, the hardware limitations I hit, and the software stack that makes it run. You might be wondering why I built this instead of just renting cloud instances. The truth is, running multi-node compute clusters in the cloud 24/7 gets incredibly expensive very fast. For example, running just 2 EC2 instances, comparable in node count and memory, even with 3-year savings plan, would cost you over $2,300 a year. This cluster paid for itself in about 7 months. On the other hand, building one massive desktop workstation gives you a compute power, but it does not teach you anything about distributed systems. A single PC does not teach you how to handle network bottlenecks, distributed job scheduling with Slurm, or parallel programming. The goal here was to build a miniature version of a real supercomputer architecture to test, break, and fix things right on my desk. Let's break down exactly what is in here and where I got it. The backbone of this cluster is 4 Lenovo M715Q tiny PCs with Ryzen 5 processors. 2 of them serve as CPU compute nodes, 1 handles cluster management, and 1 is used for visualization. I hunted these down on eBay for under $100 each. I also bought the RAM upgrades on eBay to save money. For the GPU node, I used an HP Envy TE1. I bought this locally on Craigslist for $400. Unfortunately, I do not have a screenshot for that one, just a cash handoff in a parking lot. I already have a brand new RTX 5060 Ti ready to go, and later in the series, you'll see me install it inside the HP Envy. I also added 1 TB Samsung 990 Pro from Amazon for the NFS storage. A quick warning though, I bought a lot of these parts before the recent price jumps in the PC market. If you try to replicate this exact build today, your price might be a bit higher. The key is to hunt for the deals that make sense at the time. With the Nano KVM, switch, and cables, the grand total is around $1,300. At first glance, this cluster looks like a mass of mixed parts. We have Ryzen processors in the worker nodes and an Intel CPU in the GPU node. But in professional HPC environments, mixing different types of processors is completely normal. Take El Capitan, the world's fastest supercomputer. It uses AMD MI300A APUs that pack CPU and GPU cores into a single package. My cluster splits those roles across separate nodes instead, but the core idea is the same. Different types of processors working together on different parts of the workload. This home lab captures that principle at desk scale. The network is also kept simple and realistic. The internal cluster traffic is isolated on a physical gigabit switch using a 10.0.0.x subnet, while the laptop login node bridges the cluster to the outside internet via Wi-Fi. No complicated VLANs required, just pure physical isolation. This series is going to cover everything. In episode 2, we are going to dive into the hardware of these Lenovo M715Q nodes. I'll show you how to install the RAM upgrades and fix a critical BIOS settings where the integrated Vega GPU steals your system memory. We will cover installing Slurm, benchmarking the system, and eventually cleaning up this massive cable mess. All the configuration files will be on my GitHub. If building a real HPC environment on a tight budget sounds interesting, hit subscribe. I'll see you in episode 2.